Hello and welcome. Today we're looking at organic chemistry review where we're looking at aromaticity. So the first question here says, label the position showed as ortho, para, or meta position. And this is with respect to the side group, hydroxyl group, OH group. So with respect to that, you'll see that that position will be position number 1, and then you have 2, so that's 1-2 relationship. And then next position will be 3, and then the last one will be 4. So anytime you have a 1-2 relationship, like this D here, then that's called ortho. When you have a 1-3 relationship, that's meta. Same thing here, 1-3, that becomes meta. And then 1-4 relationship, that's called para. Question number 2. Draw the resonance structures for the following compound. So if you look at this aromatic compound, that's actually naphthalene, we can draw resonance, and by drawing resonance, we move 2 electrons at a time. So we move electron pairs, and because of that, we use what's called full-headed arrow. So to start with, this double bond here will move 2 electrons to become a new double bond there. And then this other double bond will move here to give that double bond. And then the last step will be this double bond moving there to give you this double bond. And we have to use a resonance arrow like that. Next, we now focus on the next ring, and then we move this double bond here, and that now gives you this double bond here. At the same time, we move this one here to give you this double bond, and then lastly, we move this double bond here to give you this double bond. And that will be the last resonance structure. The more resonance structure you have, the more stable the aromatic compound is. Question number 3. Using the 4n plus 2 pi rule, that's called Huckel's rule for aromaticity, label the following structures as either aromatic, non-aromatic, or anti-aromatic. Okay, let's look at the first structure. So there are 3 rules that we need to follow. Number 1, is that structure cyclic? Yes, it is cyclic, so we put a check mark. Number 2, do you have a continuous conjugation or continuous p orbital? And you can see that this has pi bond, has pi, pi, and pi. So you have a continuous overlap of p orbitals, so that's yes. And then lastly, how many electrons do you have in there? Inside the ring. So here, each double bond is 2 electrons. That's 2 electrons, but that one is outside the ring. We don't count that. So that means we are only left with these 2 and 2 inside the ring. That gives you a total of 4 pi electrons. And because we have 4 pi, it does not satisfy 4n plus 2 pi, because 4n plus 2 pi, if n is 0, then it becomes 0 plus 2 pi, which gives you 2 electrons. If n is 1, it becomes 4 times 1, which is 4 plus 2, that gives you 6 electrons. So we need to have 2, 6, 10, 14 electrons for it to satisfy the 4n plus 2 pi. But this one satisfies for 4n pi electrons, and because of that, it becomes what we call anti-aromatic. So it becomes highly unstable. Next structure it's cyclic, so it's a cyclic system, yes. Continuous p orbital, yes, because that one has an empty p orbital. The plus charge is on a p orbital, so it has an empty p orbital, and therefore you have an overlap with the other p orbitals on the other double bonds. So you have a continuous p orbital or continuous conjugation. So that's true. And then how many electrons in the ring? So the positive charge has no electrons, and then each double bond is 2, 2, and 2, giving you a total of 6 pi electrons. And we saw that for aromaticity, we need 2, 6, 10, or 14. And therefore, because we have 6, then it satisfies the Huckel's rule for aromaticity, and therefore this compound is aromatic. Last structure, we can see that this structure is cyclic, yes. Number 2, it has continuous p because each corner has a double bond, or here it has a negative charge. That means 2 electrons on a p orbital. So you have a continuous overlap of p orbitals. And then lastly, count how many electrons are in the ring. We have 2, 2, and negative charge is also 2 electrons, so that gives you a total of 6 pi electrons, and therefore that satisfies the 4n plus 2 pi electrons, and therefore this structure is also aromatic. Aromatic structures are very stable. They are planar, that means they are flat. Thank you. Please support the channel by subscribing.